Okay, so we talked about valence electrons, and valence electrons are how atoms bond with each other. And then we talked about ionic bonds and how 8 is that magic number with the bonding, and sometimes they have one valence electron, or 7, and they want to have 8. So they might take one from the 1, or the 1 might give that up. And when that happens, they gain positive and negative charges, which means they now attract each other and form a bond. Covalent bonds are different in the fact that they're just shared. Like it's like we have 4 and we have 4. Oh, let's just share them. Or we have 5 and 3. Let's just share them. That's kind of how covalent bonds work. So they're bonds that are formed when 2 atoms share the electrons. They're not shared. Well, we'll talk about that later. But for the most part, they share them very equally, and they attract the shared electrons at the same time. So, for instance, here we're showing a water molecule. In the water molecule, hydrogen, they each have 1. And they pair up with oxygen that has 6. So they share 1 here and they share 1 here. So this is a covalently bonded molecule. And now they have 8 because we count them for both. So 1, 2, 3, 4, 5, 6, 7, 8 for the oxygen, same thing for hydrogen, same thing for hydrogen. Those shared ones count for both. Okay, because they share them equally. Same thing here is going on with hydrogen and nitrogen coming together. So nitrogen has 5, which means it needs 3 hydrogen bonds for it to make a 8 on the outside there. And it's another one where they're sharing. It's a covalent bond, so they're sharing these. So if I go around and count, there's 8 for each one of these because we count the shared ones for both. Okay, so sometimes the way that things bond, they create what we call double bonds or even triple bonds that are taking place here. So a double bond is formed when 2 pairs of electrons are shared and the shared pairs count for both atoms. The same thing with triple bonds. 3 pairs of electrons are shared and the shared pairs count for both atoms. So here we've got a diatomic molecule of oxygen. Oxygen has 6, which means that it has to fill up with 2 more. But they basically share those ones in the middle there. So they share 2 of their electrons, and this guy shares 2 of his electrons, which means they have a double bond sharing in this situation, which makes them covalently bonded, and they're sharing what we call a double bond. Same thing happens with carbon dioxide, another common compound that we know about. The carbon has 4. Carbon really does a good job of sharing. Usually carbon comes in all sorts of covalent bonds with other things. But it has 4, so it's sharing 2 of the oxygens over here and sharing 2 of the oxygens over here, and it also has its own 2 for each side, which means 1, 2, 3, 4, 5, 6, 7, 8 for the carbon, and then oxygen, they count those shared pairs of the carbon as well. So carbon dioxide is another one, and they're sharing them equally. And then nitrogen is another one. This is a triple bond. It bonds with itself because nitrogen has 5 in its outer shell, which means it needs to share 3 basically. So it's sharing a triple bond. And again, we count these 6 here and then these 2. And these 6 and these 2, again, that makes 8. So they share them, and the shared pairs count for both atoms. All right, properties of these are different than ionic bonds. Ionic bonds we talked about being fairly strong, so they have high melting points. They conduct electricity in water, things like that. Molecular compounds are different in the fact that they have lower melting points, and they are poor conductors of electricity. So you dissolve these in water or whatever, you're not going to be able to conduct electricity. So they don't conduct electricity, and they have much weaker bonds, which means that they have lower melting points. Ionic bonds are much stronger. Those charges that the ionic bonds have before they form their bond, when they form that bond, those charges really hold tight together. When you're just sharing them, you don't share them as strongly as when you have different charges that kind of attract each other. So they have a little bit lower melting points, and they also are poor conductors of electricity. So, of course, when I just say that we call them sharing, we, of course, have things that are unequal shared. So we have these things called polar and nonpolar bonds when we talk about covalent bonds. Nonpolar bonds are just equal sharing. So those are the ones we've talked about the whole time. They're share them equally. We call those nonpolar. If they're polar, that means one side pulls just a little bit more than the other one, creating a positive or negative charge. So here, this polar bond of the hydrogen fluoride molecule here. Fluoride pulls a little bit more on this electron that hydrogen gives it than hydrogen does, which means that hydrogen side of the molecule has a slightly positive pull, while the fluorine side of the molecule has a slightly negative pull. So we have these things called polar and nonpolar bonds when it comes to covalently bonded atoms, which makes them slightly more like ionic bonds because they have slight charges to them. So when we share them unequally, we have we have a polar bond which causes a little bit more of a pull to one end or the other of the charge, which causes slight charge to those particles, or those compounds, or those molecules that they have that are created. Obviously, they will have different properties because the attraction is slightly different if they're just being pulled equally, like in a carbon dioxide molecule that showed here. Their opposite pulling cancels because there's the slightly more negative, slightly more, but you know what happens? They're pulling, those negative charges cancel each other out. We're here, we've got a little bit positive charge on the hydrogen, a little bit negative charge on the oxygen, which means that we have a polar bond when water happens. That makes sense that water would have a slightly charged bond, would have a slight polar bond because it dissolves so many things. If it didn't have a good polar bond to it or a slight charge to it, it wouldn't allow so many things to dissolve in it. Because of that bond, it basically attracts molecules of like salt and things like that to blend in or come into the molecules of water, which causes a solution to be created. So water is one of the most highly known of the polar molecules that are created through a covalently bonded atom. This is the end of talking about creation of bonds. We talked about ionic, we talked about covalent. That's about it as far as bonding goes. You'll probably talk a lot more about this in high school. I will, on the Zoom meeting, one of the Zoom meetings we're in, I'll show you how I have a covalent bonding kit where I can show you some covalently bonded atoms, what they look like in real size, because they're kind of cool, the shapes that they make, because they're three-dimensional. But there's also homework for this, obviously. This is either found in your packet you picked up or on PowerSchool Learning. You can either do it on a separate sheet of paper, print it off. When you're done, scan it, or take a picture and send it. Enjoy!